Okay, so here's video 2 for Friday's lecture. And it talks about finding a horizontal tangent. Okay? So you need to understand what horizontal tangent means. Okay? And I wrote it in blue because it's all about the derivative, especially with the word tangent there. Okay? Typically, now not always, but typically, x to the fourth looks like a w. It could be a distorted w. Okay, it could be a nice symmetric balanced w. Okay, sometimes that w really flatlines if it's a super boring x to the fourth, and it looks like that. So that's why I'm saying it's not always a w. And if it was negative, it would flip up and make m's, like the McDonald's sign. Okay, so let's just look at the idea of the basic w. Okay, horizontal tangents, horizontal, the horizon, flat. Okay, that would be there, 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 over here, this one, there, or on this big U guy, would be right at the bottom. Okay, all of those are horizontal tangents. And what's the slope of all of those blue lines? Slope is 0 on all of them because it's horizontal. So my question is, find the horizontal tangents is asking you for when is the slope 0. And that's not the average slope, it's the instantaneous slope, or the slope of the tangent line. So the question's really asking, here's what the question is. Find where f prime of x equals 0. What happens sometime in calculus is that the hard part of a question is making sure you know what the question's asking. Now that I told you this is asking find the derivative and set it equal to 0, the math is pretty easy. But you might have not known that by the wording of find horizontal tangents. So sometimes you have to be able to interpret questions into making it understandable to you. Okay? So when I do the work here, I'll box it in so we see it. So I'm going to do the work inside the red. You got to take the derivative, which is 4x cubed minus 4x plus 0. And my whole goal is to find when is the tangent slope generator, the derivative, equal to 0. Okay, so let's see. I'm going to do not add 4x over. You're going to lose an answer if you do that. Let's factor things out. If I factor out a 4x, I get x squared minus 1 equals 0. I can go 4x, x plus 1, x minus 1 equals 0. And it looks like this happens at x equals 0, x equals 1, and x equals negative 1. Okay? Now, if I wanted the y values there, so I found the x values, but if I wanted the y values, would I plug into the derivative function or the original function if I want the y values? Plug into the y function, which is the black. So if I plug in 0, I get 3. If I plug in 1, I get 2. And if I plug in negative 1, I get, negative 1, that's 1. I messed up. Sorry. So when I plug in, let's do that all over again. When I plug in 1, I get 1 minus 2 is negative 1 plus 3 is 2. Is that what I had? I don't remember. And if I plug in negative 1, I get 1 minus 2 plus 3 is still 2. Okay? So visually, when you graph this, you can kind of plot the points. 0, 1, 2, 3. 1, 2. Negative 1, 2. And I bet it looks like this. Without using a calculator, because I knew it was shaped like a W, and I found the 3 horizontal tangents, that's what I think it looks like. Okay? If you want, take your calculator out and you can check, and it will be that. Okay? So the whole idea is horizontal tangents are going to be so important in this whole chapter, the next quarter, your whole life in calculus. Because what does it help you find on this picture? What's special about this point? And what is special about these 2 points? Those guys are minimums. And this guy is a maximum. Or this is a top. And this is a bottom. And a lot of times when we graph things, we care about the extremes of tops or bottoms. So if I'm looking for tops or bottoms, I'm looking for when is the derivative 0, which is when is there a horizontal tangent. So let's take a look at the next problems. I made these up. So it says graph the following by finding all maxes and mins by finding horizontal tangents. Okay, so we'll do both of them and we'll see what they look like. Let's try the left one first. Again, this should be looking for a W. So our whole thing is we're assuming it's going to be a W, which means there could be 3 horizontal tangents. Horizontal tangents are when the derivative is 0. So when I take the derivative here, 4x cubed plus 12x squared minus 16x. I want to set that equal to 0. And you solve that. You just did the calc part. You took a derivative, you set equal to 0. The rest of this is really algebra. Okay? So I'm going to pull out a 4x, and I get x squared plus 3x minus 4 left. 4x. Oh, Mr. Bach, you made it factorable. Why, thank you. This is a 4, and this is a 1. This is a plus 4 and minus 1. So I have it at x equals 0, x equals negative 4, x equals 1. If I wanted the y values, I could plug in to the black equation. If I plug in 0, I get 0. If I plug in 1, I get 1, 5, negative 3, and yowzers. Plug in negative 4, that one's huge. So let's see, if I plug in negative 4 with this, I got 4x cubed. Oops. Remember, you're plugging into the black equation, x to the 4th plus 4x to the 3rd minus 8x squared. And I want to plug in negative 4. Sorry, you can't see what I'm doing, but you're doing it on your calculator as well. And I got negative 128. Visually, and this is super extreme, I have a point 0, 0. I have a point 1, negative 3. And I have a point 4, negative 4 way down here. So this guy has that W look. It's just distorted a bit. But we found our 3 horizontal tangents, which means we found a little min, a little max, and a really big min. Okay? And that's all from taking the derivative and setting equal to 0. Okay? So why don't you try the next one? If you want, you can hit pause and then solve it and then hit play and you'll see what I do on it. So hit pause and solve. Now you just hit unpause and you're going to see what I did. So x cubed looks something a lot of times like that. So I'm thinking there could be 2 places where I have a horizontal tangent. I'm going to take the derivative. 3x squared minus 3x minus 6 set equal to 0. Notice that 2 that fell from x squared just canceled with the 2 on the bottom. Okay. And I'm going to pull out a 3, and hopefully Mr. Bach made it factorable again for me. And he did. This is minus 2, this is plus 1, so I have x equals 2, x equals negative 1. When I want to plug in, I plug 2 into the top, so let's see, 2 cubed minus that, minus 12. I get negative 10 there, and here I get, let's see, plugging in the -1 into the x for the black equation, and I got 3.5. So a quick sketch would be over at 2, it's way down here, and at -1, it's up a little bit, so it looks something like that, where I have one horizontal tangent, another horizontal tangent. This is a little max, and this is a little min. Okay? So horizontal tangents are so important because they help you find turnaround points to graphs where you have maxes and mins. Okay, this was a little bit shorter of a video. It just talked about horizontal tangents, okay? Finding max and mins with it, which meant setting the derivative equal to 0. The next video will be the new stuff, okay? And it's not too bad. It's just adding on more tricks of the trade with derivatives. So you can start that one now.